Hello, today we're going to do lesson 11.6 part 2. First, we're going to go over your homework and make sure you understand what you got wrong. So for the homework, number 1, you're going to break up number 5 I should say. The square root of 180 can be broken up into the square root of 36 times the square root of 5. That's how we got an answer of 6 root 5. For number 6, I can break up 40 into root 4 times root 10. The square root of 4 is 2, and you leave the root 10. For 7, this had a large perfect square factor, 324 times 2, which leaves you with 18 root 2. Now, if you have a different answer, but the number under the radical is divisible by 4, 9, or 16, or any perfect square, you have to keep going. For 8, now we have the variables. We want to break up m to the 5th into m to the 4th times m, and we want to break up n to the 3rd into n squared times n. I know the square root of m to the 4th is m squared. I know the square root of n squared is n, and I'm left with mn under the radical. Number 9, I can break up 32 into root 16 and root 2. I know the square root of x to the 4th, so I don't have to break that up. And the square root of y to the 3rd, I'm going to break up into root y squared and root y. The square root of 16 is 4. The square root of x to the 4th is x squared. The square root of y squared is y. And if you stay organized, you're left with root 2y. For 10, you can break up 200 into root 100 and root 2. And you know the square root of a squared, and you're just left with a root b. So the square root of 100 is 10. The square root of a squared is a, which leaves you with root 2b. All right, we're on to number 17. This one's a little easier. You just leave it as the square root of 17 over 5, because you know the square root of 25 is 5. Same with 12. Root 7 over root 16 simplifies to root 7 over 4. For 13, it would be root 6 over the square root of 49, which is 7. For 14, you would have root b over root c squared, which is just root b over c. Now 15 is more difficult. First, I recommend simplifying the fraction under the radical. So they're both divisible by a 4x, which leaves you with 4x squared divided by 4x is just 1x. 36x divided by 4x is just 9. So I can reduce that to root x over root 9 or root x over 3. For 16, all you can divide out is a to the 3rd. So you'd be left with the square root of 7a over the square root of 9, which is root 7a over 3. I hope this helps with your homework. Now we're going to go back to 11.6 classwork and finish up the packet. All right. Remember, if you have an even-powered variable, you already know the square root of that, and you know the square root of 4 is 2. For 108, believe it or not, 36 and 3 would multiply to 108, and you know the square root of 25. So since the square root of 36 is 6, that comes out in front of the radical, 6 root 3 over 5. Just a heads up, if you could divide out a common factor of these two numbers, you would have to. But in this case, 6 and 5 do not have a common factor other than 1. All right, for the next one, I have root 9, and I'm going to break up x to the 3rd into root x squared and root x. My denominator, I already know the square root of. So this leaves me with 3x root x over 4. Because I know the square root of 9 is 3, I know the square root of x squared is x, and I know the square root of 16 is 4. All right, the next one, let's break up 20 into root 4 and root 5. The denominator I already know is 7. So my final answer in the most simplified form would be 2 root 5 over 7. You have to break up the 20 if you can. We know the square root of both of these, so we would just have p to the 3rd over q to the 5th. That was a nice one. Up top here, let's break up z to the 5th into z to the 4th and z, and the bottom you already know the square root of. So you would be left with z squared root z over 5y. Sometimes they give us story problems. I'm not sure how familiar we all are with the quadratic formula. The Pythagorean theorem. But the Pythagorean theorem says that with any right triangle, I can square the side lengths, the leg lengths, and I will get the length of the hypotenuse squared. So in this example, we know A and B, and we're trying to find the hypotenuse C. Basically, we have to do 250 squared plus 250 squared equals C squared. When you type all this in on your calculator, you would get 125,000 equals c squared. And now we have to take the square root. So what they're challenging us to do is simplify this square root. If you're given a calculator, you can just type it in and round, but they also ask to give the radical in simplest form. So I can break this up quite a few different ways. I chose to use root 100, root 625, and root 2, which leave me with 10 times 25 root 2, or 250 root 2. That's the most simplified radical. If you typed it into your calculator, that's 353.6. All right, same idea, using the same Pythagorean theorem. So once again, we know the leg lengths, and we're trying to find the hypotenuse of the right triangle. So 60 squared plus 60 squared equals c squared. This will reduce to 7,200 equals c squared. And basically, we have to simplify the square root of 7,200. There are a lot of ways to do this. I chose root 100, root 9, root 4, and root 2, which gives me 10 times 3 times 2 root 2, or 60 root 2. You could have simplified that in an easier way, I think. If you typed it into your calculator, it's 84.9 feet. Okay, I hope these story problems helped. You're going to do more practice activities today involving simplifying radicals. Thank you.